Right.
Exactly.
Yes, okay. The floor is yours.
Thank you for this extensive introduction.
Yeah.
And thank you, Roy, for giving the previous talk and for having us here. I mean, it's very nice to be here, and I like to talk and I like to slide, but kind of worries me that I think I have more counts than what's up with that? Anyway, a little bit about me. I grew up in a small town called Willie, which is in the kop van Noord-Holland. There's also a lot of cows there. And my neighbor actually was a cow farmer. And they had cattle, and we actually had some pet cows as well. So, and the pet versus the cattle, something, we'll get to that later. More technically, I'm almost 3 years now working as an engineer at Albert Heijn. I started working as a Java developer, but back then you were either a front-end developer, database developer, a Java developer, and you were expected to do anything in the back end. So I like personally also distributed systems and the challenges that come with that, and also platforms and more systems engineering and Docker, Kubernetes. So it was actually quite a nice match, because when I started there 3 years ago, they were having like a very traditional monolithic stack, the gigantic Oracle database, which did a lot of stuff in the background, a big monolithic Java application running on WebSphere, and a single front end. And when I started, actually, I was lucky enough to start in a team that did something novel for Albert Heijn at the time. They were building an open API platform. So we wanted to expose our APIs to third parties, but also use this as a concept for our internal customers as well, and for teams to develop their own services and have them communicate this way. And traditional infrastructure doesn't really work very well there. So we were thinking of going with Spring Boot, and then you need containers, but also something, if you have a vision of building such a service landscape, and then you need something to land that on. And we at the time had an introduction on containers and Kubernetes, and we were very fond of it. But of course, we had an on-premise hosting partner, and they couldn't just give us Kubernetes because we wanted it. And they didn't know what it was, or they knew what it was, but they had no experience with it, and neither did we, because it was pretty new at the time. I think 1.3 or so, 12 versions back, even 3 years ago. But it gave us the next best thing, which is our first pet, which was lovingly named AH.1544. It was our first machine in our entire data center that was capable of running Docker, which was pretty something at the time. I mean, it was already far away from what we were doing, and we could at least use that to build some small things. But Docker in itself is nice, but who runs Docker in production? Just Docker. Almost no one. So one Docker machine, a little bit on the tiny side, but soon enough we were wanting to move forward with it, and we convinced them to give us 3 pets, 3 Docker machines. Now we're getting somewhere, because we had those 3 pets, and we at the time, we were using Kubespray, which is, if you're familiar with Ansible, I think it's a set of Ansible modules or playbooks to spray some Kubernetes magic on your infrastructure. So we had 3 machines, which were all small anecdote. The T in AHLT stands for testing machine. So they were testing the infrastructure, so they weren't battle hardened or anything. But we had a Kubernetes cluster, and we had a small business case of a buy button on Smulweb, which was at that time not bought by a competitor yet. So they had like recipes and a small button where you could buy all the ingredients for your recipe at Albert Heijn. And that was a small microservice, micro front end. That was our first case. And we had a Kubernetes cluster, so why not run it on there? So we had our first cluster with our live API. It was a single master and 2 worker nodes. no one does that on test infrastructure, but you need a bit of cowboy mentality if you're starting up a range, right? So after that, the situation grew quite fast because everybody was very fond of the Kubernetes platform and also what it could offer us. So soon enough, we were getting more machines and we were separating our environments and our clusters in like test, acceptance, production, and a tools environment is where we host our own tools like Jenkins, Sonar, what have you. And we're starting moving everything to these platforms. And we were still using Kubespray. We were already getting a little worried with it because we were using it on-premise infrastructure, and they were not Kettle yet. They were all pets, and they were all a little bit different sometimes. And one time you tried to roll out your infrastructure and it did work, and next time it didn't. So that's the beauty of running Kubernetes on-premise. And we grew, and in 2018 we were having more and more machines, and we were starting to think a bit about Kettle already then. So you can still see our pet here in the top, in the bottom right, because they were still pets actually. They were still all made by hand. So you don't just, your machines don't turn into Kettle just because you have many of them. You just need something else for that. And we're still using Kubespray. So, Kettle versus pets. You told about this a little bit before, and we really found out that it was pretty difficult to work Kubernetes on cats or on pets because there's no real uniformity. But they were more like what a colleague of mine called snowflakes. They all looked alike, but they were all kind of different. And there was no real way to automate the life cycle and manage these machines. We had requested 3 months in a go. If you want to have a new machine or extend your cluster, we had to just wait for a couple of weeks or months for a new machine. So that's not really realistic, I would say. But fortunately, we also had a cloud journey all of a sudden, and that would give us these kind of things. You get increased flexibility, also elasticity, because at Albert Heijn we have usually very high peak loads during the Christmas season when everybody wants to do their shopping and look at their recipes from Allerhand. The rest of the year is pretty even, so at the moment we cannot really cope with it. So we have massively over-provisioned infrastructure just to handle Christmas load. That's not really elastic, I would say. And also it provides you with a nicer level of abstraction, because request a VM and it will always be the same as the next one you request. So we were going with Azure as well. We had no real saying in the matter because it was company bought. I have no hard feelings against Azure. It works very nice so far. And we were still wanting to run Kubernetes on it because that is also very nice abstraction, and also allows pretty easy migration. Pick your containers from on-premise Kubernetes and put them on Azure. Works very well in theory. But what were the challenges that we had before we were going to deploy to the cloud and run our own on-premise clusters? Well, mostly operations. You have to do a lot of vetting on your pets, and there was things going wrong on all machines from time to time. You have to reboot them because they were behaving strangely or they needed kernel patches, and a lot of work goes into that. And also upgrades. We did a number of upgrades and none of them went very well. Actually, some of them went pretty bad. And we're now stuck at Kubernetes 1.8, which is a version already 2 years old, I think. And we could probably upgrade, but there's no way we're going to do that. It's just too difficult, too dangerous, stuff will break. And also we run our own Kubernetes flavor, and so we have to think about how do we do role-based access control to bolt it on ourselves. For now we have admin users and non-admin users. So that's kind of a broad, simple distinction that doesn't really help. And also DevOps tooling and support. 3 years ago it was all in its infancy, and there were like projects popping up, maybe we should this, do Prometheus, and we had to discover all of these things and also install most of them by hand, and we like to get rid of them. So what to do now? We want to solve both challenges, both go to the cloud and solve our operational issues, and if it's possible, I'd like to build an awesome platform to do this. And the two things that we really would like to have for this is to have it automated, infrastructure as code for almost everything, and work via GitOps style, that all your infrastructure is basically described in Git, and if you want to change it, you issue a pull request and other people can review your code, and if it's approved, then you can roll out a new version of your infrastructure based on that. And also we like to apply the best practices from the community, because who doesn't, right? There's so many of them. So again, Azure and Kubernetes, and what do we have for to enable our vision? Well, we thought of Reinier, which is also a nice link here. But what does Reinier do? I'm not sure if everyone has ever seen Reinier or heard about it. Well, a little bit. It's not maybe not too well known, but for us it offers CAS, and that's we like CAS at Albert Heijn because it's the most searched term I think on our product search page. Because customers like CAS. There you go, and now we do too. But Reinier offers us like an open source solution for Kubernetes as a service. It has a very good role-based access control mechanism built in. We tied it to our LDAP, and we can make clusters that have different projects and namespaces and give rights based on these projects. It also has built-in logging, monitoring and alerting out of the box, and offers other tools and best practices, so you get Prometheus, Grafana and dashboards, whatever. And also very nice, it's multi-cloud, so it runs on Azure. It also runs on AKS, which is the Azure Kubernetes service, which is slightly different. But on Amazon, Google Cloud, and even you can provision your own on-premise clusters with it, which we are also planning to do for our, because we're not fully gotten rid of our on-premise cluster. We try to see if we can use Reinier for that as well. It's like a uniform solution for all the clusters that you could have. And then in this case, Reinier for us would be our single point of interest to whichever cluster we have. So that's nice. We now have 4 clusters on premise, but with Reinier and the cloud, you have potentially very many clusters. So you can also separate your concerns a bit better. So make separate clusters for CI/CD pipelines, so agents that can be very big agents, for example, big machines, and have smaller ones for other toolings. Can make sure that all your test acceptance and production systems are more or less the same, at least from that point of view. And nice thing is also that there's a pretty low overhead for a cluster. If you work via GitOps, then you can request a cluster, can make a cluster by just adding a YAML file in our Git repository, which is I think 50 lines including comments, so it's pretty small. And then Reinier can make a cluster from that. And as a bonus, also the running overhead of AKS is pretty small. Usually when you want to make a production ready cluster, you have at least 3 master nodes, which are 3 VMs, and then all your worker nodes. And for AKS you don't see the control plane nodes, you don't see any master nodes, so I can make one cluster of 10 machines, 2 or 5, it doesn't really matter cost-wise. And also not really, well, operational-wise. Ideally. 3. So what is this GitOps thing, or the way we see GitOps is that you use pull requests and text-based files to describe your infrastructure. So for example, I created a cluster this morning for this meetup, and I just described, okay, this is an operational part at the top, who to notify, who requested. So there's a channel name, which is a chat channel where alerts go through. There's a cluster which has a name, meetup, it runs in an acceptance environment. There's a little bit of authorization, which teams get access to what, and what kind of nodes you want on there. So we use standard D2SV3, which are 2 CPU nodes. Standard Azure stuff. And there's also projects, so you can define multiple projects on a cluster. For example, I have a meetup project with 2 namespaces and a set of owners and a set of members who can work with the cluster but cannot do administrative stuff. And you can make a whole list of projects in there and have a really fine-grained way of controlling access. And also, well, we have been developing this platform based on Ansible, and we also support some add-ons. So we support FluentD, which is also just a switch to enable it in Reinier. There's a key vault add-on we offer, where you can synchronize your keys from the Azure Key Vault to your Kubernetes secrets, for example. There's auto-scaling, backup, and dynatrace. So in my team supports these kind of add-ons. Most of the time they're just Helm charts or the whole build stuff. And that's our GitOps thing. So one step back, how do we roll these clusters? Because we want to run Reinier, which is also an application that runs in Docker. But if you want to run it highly available, you have to run it on a Kubernetes cluster. So that's a kind of a chicken and egg problem. But what we did, actually we used Terraform to roll out our infrastructure. And Terraform in this case creates a very bare bones Kubernetes cluster, AKS cluster on Azure. And then we use Ansible to configure it with Reinier. So these are very tiny clusters that just run a highly available Reinier. And we have a dev test acceptance and production Reinier. And now we have these Reiniers, and then we have like a dev Reinier. And we use Ansible to create the clusters in there and to also configure them. So dev to create dev clusters, test for test, and what have you, and production for production. But the issue that we had was that dev Reinier is also our development Reinier. We develop the Reinier product. So if we break dev, then we don't want to break other dev clusters. So we put in another production Reinier, because why not, and use that one to create development, testing, Kubernetes clusters for other teams. So, it's all very great, but is it? Well, the good thing is that when Reinier works, it works usually pretty well, and I will show you a small demo if you are interested. Of course you are. But also development of Kubernetes and also AKS goes so immensely fast. You have almost no way of keeping track of it and keeping up with it. So Microsoft is very quickly adding features to AKS. For example, cluster auto-scaling, where you can automatically add nodes to your cluster if the load increases, for example. What kind of metrics do you have? There's also something called node pools. So for now you have one set of machines that is used for all your cluster, but with node pools you can have different sets and scale them. You have small machines and big machines, so you can add more of the small, and they're all in pools. There's also something called a virtual node, which is a virtual kubelet. It's serverless, but then for Kubernetes, so you run a container not on a node, but on a virtual node. It's serverless to the next level. But of course, you need Reinier API support before you can use them, which means we cannot use them, which is too bad. Most of these things, do you really need them? I don't know, the virtual node has its limitations. Cluster auto-scaling is very handy, but it's also pretty simple to implement yourself. We implemented an operator that watches for the current load and see how much spare capacity there is and can scale up or down. And we can control that, so it's pretty easy, and you can pretty well see what it is doing and when it's scaling up and when it's scaling down. And the comment I hear from autoscalers from Google, for example, is that they can work with scaling up very well, and scaling down not so much. So one of our reasons was cost reduction, and if your cluster can scale up to infinity but not down, okay, well, that's not really cost reduction, right? And sadly, I was very happy to inform you that everything you do via Reinier is cluster agnostic, so you can work on Google or Amazon or Azure, whatever you want, and if you want to migrate to another one, you just point your Reinier in a different direction and it will just work. But of course, that's not really the case. And especially we have a trajectory at Albert Heijn to move to Azure and not to the generic cloud. So we have also other departments that manage the networking. We have to conform and we have to do a lot of work on the networking part before we can create clusters. And also after the cluster is deleted, we also have to run some code to clean up Azure resources. Fortunately, many of these things can be automated, and we do. So I have a small demo if you are interested. Otherwise, I'm going to show it anyway. Let's see how it works. So, behold, this is Reinier. This is a Reinier on an acceptance environment. There isn't much going on because it's our own acceptance Reinier. Just created a cluster. Called Meetup. I was going to show the thing in Azure DevOps as well, but it seems I'm connected to the VPN now, so it doesn't seem to work. So it's kind of like what I showed in my slides, just a little bit of YAML, and basically it contains a small description of the cluster. And the pipeline has created this for us. And well, you can see, no, there's only one right now, but you can have an overview of all the clusters that you have in here, and it kind of works like a Kubernetes dashboard as well, so you can inspect everything that's going on your cluster. So you have monitoring, like how many CPUs and memory is used. There's also, well, 2 red flags here, which doesn't look good, but actually because Reinier doesn't fully support AKS, so it complains that it cannot find the controller manager and the scheduler, which is the control plane. Of course, AKS hides that for us, so it is actually okay that it cannot find it. But you see this nice Grafana logo, so you can also just look at the. You can also look at the Grafana dashboard, which no doubt many of you have seen before. This kind of dashboard, it also integrates very well with that. It's the community best practices part that Reinier actually offers. And well, so what more is there to see? You can also just use the Reinier dashboard itself to have some kind of metrics. And I'm not sure if any of you have worked with the plain old Kubernetes dashboard before, but it's very clunky and it's oftentimes very slow. And this is a nicely integrated solution to view your monitoring and what else. So you can inspect individual nodes. So these are the nodes that are running in AKS. So you can even do some maintenance on there. So I can cordon a node and drain it. So when I have to restart a virtual machine, I can just do it from. I cannot do the actual restarting from Reinier, but I can at least make sure that I evict all the workloads from this host and then restart in the Azure portal, and then suddenly it comes back on again. So it's very, very convenient for that. And also I can do more inspections on the machine itself. So what more is there? Well, you can see what kind of storage is there for your cluster, how many volumes you have. Well, one for Grafana, Prometheus. And this is the Airbag at work. So if you remember the slides that I showed you, let's see, can I find them back? So I had some projects set up where I defined, okay, this is my meter project. I have a couple of namespaces in there, and these groups are allowed to access them. And you see this here as well. So there's the meter project. So Kubernetes doesn't have a concept of a project, but Reinier has, and you can create a number of namespaces in there, and you can well, if you have access to them as a user, you can deploy to there. Otherwise, you cannot. It actually works kind of as you would expect, which is oftentimes unusual. And in this, well, I have nothing deployed here, but you can inspect all your deployments, or you can import them here, or you can start them by hand if you want to. But usually we do everything via automation, so I'm going to skip that part. Is there anything else I can show you? See, oh yeah, there's alerting. It's very nice. It's also shows you all the alerts. You can configure this by yourself, and well, it has a list of all kinds of alerts that you have. And there's also well, now they're all active, but they're not firing. If an alert is going off, then you can also see it here. And let's see, there's also a notifier. So what happens when an alert goes off is that, well, these notifiers, so the cloud team gets notified via Rocket Chat, and also the SRE team, which is my team, gets a Rocket Chat notification if an alert goes off. Pretty nice integrated solution. So there's logging as well. So it has support for Elasticsearch, and I enabled the Elasticsearch add-on. So for me, that was just logging us, and then Reinier did all the hard work for me. So is there anything more? Well, you can also just interact with your cluster like this. So you can launch kubectl, which is the command line, to do some troubleshooting. We can download the kubeconfig file, which is something you use for well, running on your local machine with the command line. And we also use this for automation a bit, because on-premise we now have 4 clusters, and it's easy if you want to deploy to test, you always go to that test cluster. If you want to deploy to production, then there's only 1 production cluster, and now there's potentially many of them, and you don't know in advance which ones are there. But fortunately, Reinier has a very nice API. So if I, as a user, log in to my pipeline with my credentials, I can. The pipeline can only deploy to clusters that I am allowed to deploy in, and can download kubeconfig and just do Helm or whatever kind of installs you have with full RBAC support. And a nice thing to tell is that this, well, you can create clusters by hand. I can do add cluster via a button if I would want to. So you can say add some kind of cluster. But this cluster that we made was completely built by automated toolings, because otherwise you don't have any repeatable infrastructure in it. If I am making a cluster by hand, then it will no doubt be different from when my next door neighbor does it. So this is, I think, in a nutshell, what we are doing with our Kubernetes branch. Do we have something at the end? Oh yeah, thank you. And if there's any questions or any things you would like to see, would like to know, or any suggestions?
Has Reinier out of the box I saw a catalog?
A catalog, yeah, it has. The catalog is here. I haven't used that a lot. Catalog, was it the pun or?
Tools.
And tools, the catalog, you can specify Helm chart repositories, I think. And you can actually use the Reinier UI to I have to think about it, to deploy workloads. You can also use the Reinier UI if you would want to. So you can add a new workload, or you can actually, I think, what is it? Step back. I always have to find my way in this UI a bit. think it is like this. Apps, there it is. So, a multi-cluster app, that's not what I was looking for. I think if I go to this cluster, also have something. Project, no. What is the apps on? So you can do it, but I've never actually done it. But you can just start an app from here as well. And it has a, well, what do you like? You like WordPress? Search for WordPress. And then you can start a WordPress on your cluster and without knowing anything about Kubernetes or Venture or anything. So it's very nice for people that don't want to know the details but want to have at least a bit of monitoring, and it looks shiny and it works pretty well, I would say. So I can start WordPress maybe here. My WordPress. And I can select who can use this. So maybe I have some LDAP group team SRE, that's my team, so they can all access the WordPress. And basically I can configure anything as you do with a normal Helm chart, but this is with a nice UI, and I can try to launch it. API targets, okay. But that's, it has some kind of, I think I did something wrong.
It's just clear, that's very good.
Yeah, I cannot really see the screen from here. I think I needed this, the description of what WordPress does. This is required, so let's say this is my WordPress. And then can't really see it. API targets, where is it? Oh yeah, of course. I have to say where I have to run, where I want to run it in. So it is in the Meetup ACC cluster, in the Meetup project. Do I have to say anything more? Target projects. So do I need to do anything? Not sure. Of course my user doesn't have project member. So I'm a project owner, but I'm not a project member. So I do own the cluster, but I cannot deploy to it. We're not running in production here, so we have to think about how these RBAC things are supposed to work. But again, you can configure all of that. It's pretty nice so far. We're not running actual production yet through Venture.
How are applications exposed outside the cluster? Do you run some sort of a proxy?
Well, we use an Open API gateway, which is a set of Spring Boot containers which run an Open API platform, and they have OAuth 2 and all the things embedded, and usually that's where most of our traffic goes to the outside. But we also have front ends running in Docker, and the load balancer in front of all the traffic that goes to our infrastructure, and we use ingress on the Kubernetes side to direct the traffic to the correct container, which is pretty standard, I would think. So there's ingress, which is plain HTTP, and there's the OAuth 2 API gateway, which is for the services.
I have a question. As I recall, you mentioned upgrading Kubernetes is quite a hassle.
On premise, yes.
Yes, on premise. So
well, for us it has proven to be quite difficult.
Okay.
And we also have to test it in the cloud, of course.
Okay, and now you're running in the cloud, and then the updates are performed for you.
Well, you can for Azure you can say update my cluster to this next version, and supposedly a one-button click. But I haven't seen it in action live yet, so we have to invest some time in that as well.
Yeah.
Because if it then breaks, what are you going to do with your kettle? I mean, you cannot pet them, or you can log into one of the VMs, but then it's a completely different story. That's maybe the downside of it. You have very little control over that. You just have to assume that everything goes well. But
Yeah.
I've seen AKS cluster updates go wrong more often than they go right in the past. So
And
we have to see
any
what
idea what's the problem behind that? Why didn't
I'd
upgrade
love to
it
know
well?
that. I don't know why it's so complicated.
No, but is it the code? It's the containers itself are not running on that?
No, because we also attempted back in the day when AKS was just new, attempted to just upgrade a cluster which had nothing pretty much running on it, and that could also fail. But I think this is like over a year ago, and AKS is pretty new, and it was not really rock solid back then. But for now, it hasn't proven to be unreliable or anything.
Okay.
We don't use it as heavy as we use our on-prem cluster, so we have to see how it behaves when we scale up. But for now, it looks very, very well suited to what we want to do with it.
Yeah. And about the scaling, the automatic scale out, I presume, and the scale down, the scale in. Have you experience with that already?
Well, one of my colleagues, because we cannot
The
use
autoscaling, I mean the autoscaling.
the node autoscaling.
Yeah. Sorry?
You mean the autoscaling? node?
Autoscaling, yeah.
Yeah. So as mentioned, we cannot use the Azure provided autoscaling because Reinier doesn't support it yet. But basically, what one of my colleagues has written is a small application that checks the reserved capacity and the actual used capacity, and it compares it, and if there's less than so much CPUs available, then it will scale up.
Yeah.
And basically, it does a scale up via the Azure API, so it's just as well as me doing a click in the Azure portal. So it goes completely bypassing Reinier.
Okay.
And it can also scale down. The nice thing is that we control it, so we can tell it, okay, if you have so much slack, then scale down. If you and if it's too tight, then you scale up.
Yeah, I understand.
But yeah, that's it. Actually, is more reassuring than have Microsoft take care of it, because then you basically don't know what's happening. Right? I have no idea.
I
They're
don't
out to
know. I
scale
haven't
for
used it,
us.
but I can imagine that there are also some things you can adjust so that it will be conform your needs.
Yeah, what I've
Isn't
seen
that
so
the
far,
case?
if you create a cluster by hand from the portal, then it's yes or no.
Okay.
So that's
Yeah.
well, you cannot do anything wrong with that, but also you cannot tweak it. So you have no idea basically what happens.
Okay.
And as I said, we heard from people using Google Kubernetes that it works very well for scaling up, and not so much for scaling down.
Of course.
Of course, yeah. I mean, cloud vendors, you gotta make a living, right? They don't have it very easy. So, is there anyone else wants to see? So no, I don't know, this is like a competitor to OpenShift maybe?
Could you tell me a bit about logging inside the system? As you mentioned, well, we're still working with pets instead of cattle, that's CRV, and once you will have to learn to work with cattle, having multiple instances of the same application running, you have to distinguish where things got wrong. How is logging getting this information available to find out where your application has gone wrong?
Well, for logging we use the built-in log aggregator, which is Fluentd, I think, and you can push your logging information to an Elk stack somewhere. Reinier doesn't provide it, but it has to be somewhere. And I think I don't look at the logging myself very much. We use Dynatrace as well, which is more for troubleshooting, is a little more elaborate and more for tracing. So for logging, I have to admit I don't know that much about it. I think we can you can see all kinds of labels to see if it's which application was logging kind of things. You can search on it in Elk. It's very powerful. I don't know most of the details about it. Because of the times that I've used Kibana to search for some logging, I could never find what I was looking for. To be like a wizard in it, for example. So, then I suppose there's no more questions. That's it. Thank you very much.